Okay. Hello everyone and welcome to this introduction seminar to the describing the frame agreement, the recently signed frame agreement between Karolinska Institutet and Testa Center. What it means for research group as KI and how you can use it and how you can utilize the Testa Center. The agenda for today is me to present Protein Science Facility, and then Jesper to present Testa Center, and then we have some presentation about funding opportunities also towards work at Testa Center. So an introduction to protein production at Protein Science Facility. We started in 2011 as a core facility here at Karolinska Institutet. So we've been going we had 10-year anniversary just recently. We are currently funded by KI and VR, and we're also recently started a national infrastructure protein production distributed infrastructure funded by VR. And this is under construction and will open up in the beginning of 2021. The Protein Science Facility has 3 parts: protein production, services, biophysical characterization, and macromolecular crystallography. For the protein production, we offer services only. Biophysical characterization of proteins, we have instrumentation such as biocore and calorimetry and others. And there we offer services, but also, or mainly, user training and access to instruments. And the same goes for the crystallography robotics we have. And today is mostly about protein production or macromolecular production. But within the PSF, what we offer here is, first of all, project evaluation. We lend our expertise to evaluate a new project, examine its feasibility, come with the good suggestions and design of a project. Construct design. Are we going to work with a full-length protein? Are we going to work with truncated proteins? Single domains? What affinity tags should we use? Solubility tags, etc. We have molecular biology services such as cloning. We can do high throughput cloning in 96-well format if necessary. With all types of vectors and DNA, of course. Although today much or most actually constructs, particularly single constructs, is synthesized and ordered from companies who are more efficient than I think any academic lab can be today. We offer expression and solubility screening, which is important before you go to the scale-up, of course, to evaluate target feasibility, the expression system, and the right cells. We work with expression systems such as E. coli, mammalian cells, and also insect cells. And the volumes we work with is between, well, it's liter scale, up to 20 liters or 30 liters. Mostly between 1 liter up to maybe 6 liters, the most common. And during these 10 years, we have worked with around 260 unique PI groups or user groups, both from academia and industry, and also a couple of foreign universities. And we see that mainly between 50 and 60% of all our users are from KI yearly, naturally. This is where we reside. Maybe 70 to 75% of our users are from the Stockholm area, also Stockholm University and KTH. But then we have had quite extensive work with all the main large universities in Sweden over the years, as you see, and about 10% yearly non-academic users from industry. So this year we worked out a frame agreement between KI and Testa Center, so that users from KI who need much larger scale than what we can offer in an academic laboratory can turn to Testa Center for that, for culturing of cells, for expression cultures, and the production of biomolecules, not only proteins. This agreement is for 2 years now, with the possibility to extend. And the Protein Science Facility will act to help and guide users from KI to approach Testa Center and to evaluate and help to design the best conditions to succeed at these very large scales at Testa Center. And with that, I will leave the word to Jesper from Testa Center. Thank you.
Thanks a lot for that, Tomas. Hi everyone, my name is Jesper Hedberg. I will change slides right now. I'm the director of Testa Center. So I'll talk a little bit about Testa Center and of course refer to how we're going to work together with PSF. I'll give some background and then I'll give 2 examples of projects that's been run in Testa Center, what they actually achieved in Testa Center. One which is an example of mammalian cell culture and protein expression, and one which is a microbial culture and protein expression. And then I'll end off by saying a couple of words about a activity that we'll have in the beginning of next year, which we call Testa Challenge, as a little teaser. And after that, I'll leave over to Malin to describe some of the funding opportunities that is also available for projects in Testa Center. And I'll also say hi to everyone on link. And if I am correctly informed, we are recording this as well, right?
Yes, and you can ask questions in the chat.
So please ask questions at any point, of course in the room and in the chat for you guys in the link. So hopefully I'll do this within 30 minutes and we'll can get off to our meetings at 1 o'clock later on then, because we're all booked, right, in teams all over. So what is Testa Center then? Testa Center is a test bed or a research facility for biological production in a little bit larger scale, what we call bioprocessing scale. Our vision is that we together, and that is of course Testa Center staff, projects at Testa Center, and various service providers such as instrument providers or consultancy providers, actually change the journey of world-changing innovations that we are all working with. And we do this by enabling researchers and both academic and companies, of course, to verify their innovations in an environment which is relevant for industrial applications. So larger scale protein production. This you can do either as most commonly used by our academic groups to generate larger amounts of protein for their research, for experiments. As a company, you usually want to show scalability, for instance. So both researchers and companies are utilizing the Testa Center facility to verify their innovation. And then also accelerate industrialization, of course. We have a third leg that we also stand on quite firmly, that is to secure the excellence around biological production. So we all know that biological drugs has gained lots of market shares the last 10 years. So 10 years ago, there weren't many biological drugs at all launched. Today, we're reaching about 50-50 split between small molecules and therapeutic proteins, for instance. So securing the excellence is a big thing for the industry, I would say, and also the academic world. So we are what we call a test bed. I could describe us as a research facility as well for production of biological products. We are accessible for academia. We're accessible for startups and larger industry. We're also have the possibility to enable verification of both biological innovations, typically new types of proteins, new types of cells, or just generating larger amounts of proteins. But we can also enable verification of technological innovations within the realm of biological production. We describe ourselves as an industrial infrastructure lab in pilot scale. So what does that mean then? For us, that means that the labs are designed as a production floor for biological production, and the instrumentation can be used to generate large amounts of proteins. I'll come to that. Importantly, we're non-GMP, so you cannot generate proteins for clinical trials in Testa Center, but you can generate proteins, for instance, for in vivo studies in animals and show scalability and larger amounts of proteins. We're a non-profit legal entity, so the intention is not to generate cash. We do, however, need to cover our costs to be sustainable over time, but the intention is to go break even. So what do you get when you come to Testa Center? Of course, you get access to a bioprocessing lab, including the equipment that is needed for large-scale protein production. I'll come to a slide just after this one, which is a little bit more detailed than this. But typically, it's a lab which is designed for bioreactor cultures and protein productions in pilot scale. We also provide, just like PSF, like Tomas described, we provide technical support and coaching support. Always from the start, when we get engaged with researchers, we kind of discuss the feasibility of the project. Are you guys ready to enter a lab like this? So do we need to do a little bit more work than before we are ready to enter? And then when projects come to Testa Center, of course, we're there to coach and help when they run protein production in Testa Center. Important to note is that we are not a contracting lab in the sense that we don't take assignments. So as a researcher, you need to come to Testa Center, or you need to engage with Tomas, who then performs perhaps the protein production in Testa Center. We as an organization will not do a project for you and then deliver a purified protein like a contracting organization. So the intention is to be there, or at least be an intricate part of that project. What's not stated in this slide is that we do not provide chemicals. We cannot harbor all the chemicals in the world for any potential project, and we cannot harbor all the consumables in the world for any potential project either. So you need to bring that with you. So resources, chemicals, and consumables you need to bring. Apart from that, we are aimed to be a relatively all-inclusive experience. A little bit more details on the instrumentation. Now, this is the summary of the instrumentation list. You can download our complete instrumentation list from our homepage, testacenter.com. But in brief summary, we have culturing capabilities for both mammalian and microbes, mammalian cells and microbes, of course from shaker incubators, all the way up to 200 liters for E. coli. So this is an old slide. It says 200 liters coming. It's there already. So our 200-liter bioreactor is installed and has been run several times during the autumn. I don't know where I got this slide. It's definitely a couple of months old. For mammalian cells, we have bioreactors all the way up to 500 liters. Harvest, we have capabilities, of course, for batch centrifugation, regular centrifuge, but we also have a continuous centrifuge from Alfa-Laval, and then filtration possibilities for scalable techniques to harvest cells and proteins. We are situated on the SciTiva site in Uppsala. SciTiva is, by legacy, the downstream company in Uppsala, formerly known as Pharmacia Biotech, Amersham Biosciences, GE Healthcare Life Science, and all the other names that the company has had. It's basically the same company with the same service. So downstream-wise, protein purification-wise, we basically have most of the instrumentation available on the market. We do have some limited analytical capabilities. We have decided not to focus on analytical capabilities. We have decided to focus on the bioprocessing equipment. Very briefly, just to iterate what Tomas said, this is the need that we, from Karolinska, that we anticipate. So some of the process development can be done at Testa Center, if not done already at Protein Science facility. 200 liters for microbes and 500 to 500 liters for mammalian cells. And the first project is in plan and funded, excellent, for April next year. So Tomas will enter Testa Center as a pilot.
Yes.
Yes, in April next year. So that is great news, I think. I have a question.
If I would like to bring my own instrumentation, my own tools.
Yes, very good. Thanks for that. So let's go back to the instrumentation. So this is the instrumentation that we have in Testa Center currently. If you like to bring your own piece of instrumentation, that is perfectly fine, as long as we can fit it through the door. Also, when it comes with consumables, you can bring any consumable you like. Again, we can harbor it in the labs. And we need to, in terms of organisms and chemicals, we need to adhere to the environmental permits that we have for the site in Uppsala. But the site's been around since the 60s, so we have not found yet one chemicals that have not been permitted on the site during our 3 years in action. Yes, please, another question.
About the chemical you bring, but since it's in SciLifeLab, so you will provide all the gel, the chromatography resin, right?
So we define the chromatography resin as a consumable. So you need to bring that yourself.
Okay.
Yes. But there is, of course, great support to get around chromatography on the SciTiva site in Uppsala. Excellent. More questions?
The wave bioreactors.
Yes.
What volume do they go up to?
So the wave bioreactors are all the way up to 25 liter of culture volume. So it's a 50 liter bag where you can fit 25 liters of cell culture media. It's a little bit confusing, those numbers. So 25 liters of cell culture is the maximum. You can push it a couple of liters more.
Yeah.
It's not recommended, but you can actually do that.
10% more. But
Yeah.
do you have several of those? So is that as far as it goes? And if you want to go more, then you would have to go into the bioreactors.
So for the waves, we actually have 5 of them.
Mm-hmm.
So if you want to book and run 5 waves in parallel, you're more than welcome, provided that they're unbooked when you book them. But if you want to do more or larger volumes than that, I would recommend to go into stir tank. So which is the XDR 50 for 50 liter, XDR 200 for 200 liter, and XDR 500 for 500 liters. So those are the maximum volumes we have. I guess we could fit a 1,000 liter bioreactor if we like, but we don't have that yet. So, but that's the great questions. Any more? No? Then I will try to describe a couple of projects. These are then slides that I have gotten from the researchers been here. So please excuse my ignorance if I say something wrong. So this was a project run by Marika Nestor and her colleagues in Testa Center. She is just now exiting the DDD platform here from the SciLifeLab here in Stockholm. She has a candidate drug, an IgG1 antibody, which they have developed in the DDD platform, and she is now considering how to take this forward. Now, she had a couple of needs that she needed to establish or fulfill before entering the next step in her project. So that was, for instance, establishing a stable cell line. She got great help from the SciLifeLab around that, Anders Olsson in the SciLifeLab. And then she needed to establish a first draft, I would say, of a production procedure, which meant that she needs to establish a culture procedure in upscale and then a protein purification procedure in downscale. She did some optimization work in the in small scale shaker flask in SciLifeLab before she entered the Testa Center. And her aim was then to get more than 100 milligrams of stably expressed protein. And this is Anisha. She did her ex-job, her master thesis, together with Gustav also did his master thesis in Testa Center. Anisha is right here, if you like to ask her questions. And basically they went from SciLifeLab into shaker flask in SciLifeLab, into bioreactor in Testa Center, and of course also purification in Testa Center. And there we go. They actually kind of overshot their goal a little bit by tenfold times, and then generated material which are now used by her in a variety of experiments that taking her project forward. So purity, stability, aggregation, and antigen binding. And she also uses the protein for in vivo studies. So I would say this is a very nice example of a project. Not only did the thesis students get jobs after the project, they actually generated some material and took that towards, one step towards the market actually. Another project which we had just prior to the summer was Gustav Berggren and Marco Lorenzi from Uppsala University. They have a protein, a hydrogenase, which they utilize in their lab. They do characterization of the enzymatic reaction, and they needed to these protein to be expressed. They express some protein, purify this protein to do the assays in the lab. Now, one limiting step for them is that this is a low expression protein. They need a lot of material to do the experiments that they want to do, and which meant that Marco is purifying protein every month to do these experiments. And then he does the experiments for 3 weeks. He runs out of protein, then he needs to do another prep. So we kind of started to discuss together, could we kind of help them to get more protein basically. So again, we went from shaker flask into bioreactors, which then enabled them first off to control the culture much more carefully, which increased the optical density, the cell density, by 7 to 10 times. And we also switched the batch centrifugation for a filtration method, and we went from a high trap scale to a little bit larger scale. Purification, I don't know exactly how large, but say a couple of 100 milliliters of resin instead of, say, 1 to 5 milliliter resin, which means that they not only generated more material in the upstream, they did it in larger scale, and they got lots of protein, which basically is enough for him for the rest of his PhD period. So we think that's a good way to help. Right, so that's typical examples of projects which we think are beneficial. Right, I should show this. I almost don't even know the abbreviations here, but he can now do his Fourier transform IR spectroscopy and his EPR spectroscopy experiments, and he's also aiming for a neutron diffraction experiment at the ESS in Lund. 2 examples on how to utilize Testa Center. Now, not everyone are familiar with running bioreactors. You might not, shaker flasks often you might know, but going into bioreactor is often a big step for many. I'm going to jump a couple of slides and say a word about support. So there are expert support to get in Testa Center. We are staffed by upstream and downstream specialists. This is actually Charlotte. She has just rotated back to Cytiva R&D, but she's been replaced by Louise, another girl who supports on downstream a lot. And we also have an upstream support. And when PSF and Karolinska Institutet researchers come to Testa Center, I would expect that Tomas also will support from their organization. Or actually you promised that, so let's hope for that. And so the intention is that even though that you're not super familiar with doing large-scale cultures above, say, 50 liters, the absolute intention is that we should support the researchers coming to Testa Center so that you have the ability to do that and to learn and to develop your project in that scale. All right. Now just a couple of words. We also have a biosafety level class 2. So this spring we had the gene therapy project running in Testa Center. They put a industrialized process in place within actually 10 weeks. We have a great testimonial story of that on our homepage, so please Google it if you like. That's the Testa Center. Now I did say that we also can harbor technical innovations in Testa Center. So this is what Testa Challenge is for, basically. So if you have a sensor, say that you're a sensor researcher, you might not be super keen on running a bioreactor. That's not what you're trained for, right? You're very, of course, into your sensor. You might not be super keen on purifying and harvesting protein. You want to verify your sensor. Now, in the beginning, we thought that these companies were coming into Testa Center and we could matchmake them with biological projects running a bioreactor anyway. Now, that doesn't pan out very well because the guys running a bioreactor want to do that. They don't want to verify a sensor for anyone else. They want to run a bioreactor only. Which meant that the sensor or the digital projects kind of were, we didn't get the traction that we wanted. Now, how to solve this? So we basically decided that let's gather some money, let's gather some funding, and we'll run a bioprocess for these guys. And we'll open a call and invite them to be a part of a bioprocess run in Testa Center, free of charge. So we did that a year ago. That was the Testa Challenge 2020. It was very, very successful. Now we applied for some more money and we're going to do it again. So in March next year, we're going to run a bioprocess, mammalian cell culture in 25 liter scale, we think, depending a little bit, and then we'll open it for innovators who want to be a part of this project to verify their technical gadget, sensor, digital application in a bioprocess environment together with us. And this is right now in planning. We'll launch it Wednesday, or will we launch it next week? We'll see. Somewhere very close now. There's going to be an application period. There's going to be a project selection, and then we'll start the experimental planning in the beginning of next year to do the actual experiments in March next year. So if you're interested, please Google Testa Challenge and check out our teaser. Now I'm coming to the end. Testa Center. We are non-profit. We provide expert support. We're a non-GMP lab for biological production, and we're a private-public partnership. You get access to unique equipment in Testa Center. You get access to expertise in Testa Center. We pay per usage, and you get a professional network. And depending on your goals, you can achieve either risk reduction or larger amount of proteins, for instance. You will increase your process know-how, and by that also your project value, we think. Very important to say, we are on the site of Cytiva, but the results that you generate in Testa Center, potential IP that you generate in Testa Center is yours and yours alone to bring with you. So no need actually to show your results even for anyone but yourselves. I need to know what you're doing in the lab for security reasons, and that we have the permits for organisms and chemicals, but I'd be happy to sign a CDA if you like. So it will be under confidentiality. Okay. These are some of the projects that have been here today, to date. And if you're interested, you're more than welcome to contact us for a discussion. So either me at testacenter.com or Malin, who is now going to say a couple of words around funding opportunities for Testa Center projects. There we go.
Yeah, thank you.
And please, if there's any questions in the chat room, just raise your hand.
Yeah. So hi, my name is Malin Wiederholm. I work at Stunds Life Science, so I'm a separate part than Testa Center. So Stunds has been collaborating with the Testa Center since the very beginning, so before there was a house and everything. And we are contributing as an independent actor sort of the neutral layer. As Jesper said, when you come to Testa, you retain your own IP and everything. So when you come, you go through us, and we help evaluate the projects that are going to come to Testa Center. So I'll tell you a bit about some funding opportunities that we have available. We have some funding for preparation, so if you need to do some things before you are ready to come to Testa Center, you can apply for what we call like a check, you can say. This is for small and medium-sized companies. You can apply for up to 250,000 crowns, and there's a co-funding depending on the amount you apply for, between 25 and 50%. And proposals are welcome continuously, and we will evaluate this. So we have one project ongoing that are making a market analysis to generate KPIs. And also, if you have anything that you think Testa Center could be interested for you to use, you can always contact me or Anisha. Yes,
Right.
I think
Thanks a
we're...
lot, Malin.
I have a question.
Yes,
This is open for all Swedish
yeah,
academia or small SMEs or,
Yes.
yeah, not
all
only
over.
Uppsala.
No, not only Uppsala, it's nationwide. Yes.
Perfect. I'll step into frame. And with that, we don't have a closing slide, I see. Let's go back to me then. Somewhere there. Sorry. So with that, if we have any questions on the chat, I'll be happy to answer. Or anything in the room, of course, me, Malin, or Tomas will be happy to answer. But apart from that, we're closing up on time. Yes?
You only start with the stable cell line. You do not do any transient transfection, for example.
So you can do transient expression in Testa Center as well. Now, when you go up in scale, we've done some calculations on this. When you go up in scale, so say above 10 or 15 liters, the transfection agent cost runs very, very high, very, very quickly. So we've had discussions with projects that have thought about doing transient expression at scale, but we always went with the decision, now let's go with a semi-stable cell line or a pool of cells instead, not necessarily a clone. So that is a trade-off. So the answer is you can do it. It just depends on what you think is most cost-effective for you. Great questions. Anything more? Yes?
Yeah, what is your most popular service at the moment? What are most people using?
Actually, our 200-liter bioreactor for microbes has been very, very popular this autumn. Now we just started it in August, so maybe it's the first the first immediate need. But it seems like that is quite popular. I mean, having access to 200-liter bioreactor is not. It's a costly piece of instrumentation, and you don't need it every day, which means that coming to Testa Center, if you have that need, is a very good solution to kind of fulfill that gap. Apart from that, I would say the chromatography instrumentation is popular, of course. Yes?
People come with mammalian cell cultures.
Yes.
They usually probably grow in flasks
Yes.
in their own labs.
Yes.
How do you have a project that goes into the bioreactors, that transition? Do you have like a pre-project just to get it into the bioreactor and then a second project going to a larger volume?
So the very short answer is typically yes. And if I elaborate a little bit more, so again, if the project, you as a researcher will be responsible for your project at Testa Center, which means that you will drive it and you will make those decisions yourself. We will coach you as much as we can, and as much as you need actually. And so depending on the maturity of the project, some of the project that come to us has already done a simulated fed batch in shake flask, for instance. They have an idea of how to run a bioreactor with the cell line already from the start, which means that we usually go in bioreactors directly. Perhaps a small volume bioreactor and then a little bit larger quite quickly. We get approached by other projects which are much earlier. Perhaps they don't even have a stable cell line that we just discussed. So their first goal is to generate something that expresses the protein stably. So if it's a pool or a semi-stable cell line or actually a clone. So that's the first step. And doing the clone, for instance, so Marika and Nestor made a clone. So when they did the clone, they also did simulated fed batch experiments and continuously discussed with our upstream experts in Testa Center. They didn't do those actual experiments in Testa Center. They did that in their home lab. But we also have a very close connection with them. So giving them feedback on, okay, you got this result, perhaps you should check those variables for the next time you do your shaker flask experiments next week. So when they actually had their clone, they were quite ready to enter a bioreactor directly. There are other examples where you only have run batch. For instance, you have your shake flask batch experiments, and you need to kind of do a small pre-experiment, just as you described, to get an idea of what will the best way to run this in a fed batch experiment in a bioreactor in Testa Center. But again, some of the projects are in a big rush. They don't have the time to do that. This is what we have is good enough, and they just go for it. So depends a little bit on timelines and goals of the particular projects, I would say. So we'd be happy to discuss if you have particular needs. So let's set up an initial meeting and see if we can help. Yes.
So there's a question from the chat from
Yes. Per, yes.
Will there be any cell line development service or collaboration for those who need this?
So the scope today, I would say, is not any cell line development service from Testa Center. However, we do have collaborators, both commercial and academic collaborators, that have the possibility to help you. So without, giving out names and promising stuff for that other people do stuff, I'd be happy to if you contact me, testacenter.com, we can have an initial meeting and we'll discuss the possibilities. And that's basically organizations that we know, that we've worked with before, both commercial and academic organizations that we've worked with before, that we think is okay to work with.
And Protein Science Facility will also assist with that.
So, Tomas just says in the background, if you didn't hear that on link, so Protein Science Facility will, of course, assist with that as well. And that is both microbial and mammalian cell line.
And mammalian cells, yes.
Excellent.
Yeah.
Which then is very much better answer than what I gave. Yes.
What would you say is an average time for a project at Testa Center?
So an average time for a project in Testa Center, again, of course, depends on the goals, and also I would say depends a lot on the organism. So a microbial project, those E. coli, typically they grow much faster. So if you want to go into a bioreactor and do a couple of iterations in the bioreactor, we say 3 to 4 weeks is a typical microbial project length. Mammalian cells grow slower. Again, depends on how many bioreactors you want to run, but I'd say at least 8-10 weeks is there if you want to do upstream harvest and downstream. Mm-hmm. Now we have projects that focus, for instance, only on the midstream. They just want to try out the filtration technique. They come with a cell pellet and they do only the filtration in Testa Center and they don't do any downstream. So that's a week. So it depends. And we've had other projects that stayed for half a year. Mm-hmm. But I'd say microbes, 4, 5, 6 weeks. Mammalian cells, 8, 10, 12 weeks. Somewhere there is the most common. Mm-hmm. Great questions. More?
You also provide the perfusion culture?
So there is absolutely possibility to run perfusion cultures in Testa Center. Again, if you come with your project to Testa Center, you'll be the one who decide that. We'll help you to set the experiment design up. For instance, in Wave, there is a Wave bag with a lily pad filter, which is very user-friendly, I would say, for perfusion culture. You can also do perfusion in stir tank with TFF solutions. We don't currently have an ATF solution, but that is also an alternative. So the technical possibilities definitely exist there. If you want an example of a perfusion project that's been run in Testa Center, we have had a project from a consortium called AdBioPro, run by Véronique Chouteau at KTH. She's the PI for that. They just did a press release last week, right?
Friday.
So last Friday they did a press release on the results that they're going. They also have a very nice little YouTube video that you can check out. So they did a perfusion culture in 30 liter scale with the XDR50 over, I think, 30 days. And they generated somewhere, oh no, I don't remember the exact, but they generated protein amounts in grams scale per day during those 30 days. So it was very, very successful actually. Great questions. Anything more?
But what about this funding evaluation?
The funding evaluation.
Yeah,
So
it can be more easy to get funding. What kind of project?
So the acceptance rate of the funding, is that your direct answer question? Yes. So I would say that there's a good chance of acceptance. If you have a project which has a commercial angle, which you need to have to get the verification funding, and you also have a scalability angle where you need to show scalability and need to show industrialization of your project. Without giving any percentage or anything like that, I'd say that it's a good acceptance rate for those applications. I've seen much worse, that's for sure. Of course, it's advisory board that scores projects, and the decision is actually Vinnova's final decision. So actually, neither students or us actually have any power over those decisions. But we'll guide you to apply, of course. Good.
So say that I'm working here at KI and I would like to leverage this general agreement.
Yeah.
How do I go about it?
So I would say either contact Tomas Nyman to know details, or me, or both. Perhaps the easiest way to actually CC us both in an email, or pick up the phone. We don't use phones so much anymore, but you can Google my phone number as well. Yes. So please get in contact. Very good. I think with that was the last. Unless we have
no more questions.
No more questions, and then we'll have 4 minutes left until 13:00. We can run back to our Teams meetings in the offices. Thanks a lot for listening.
Thank you.